Good morning, class. The topic that I will discuss to you today is sampling methodology. Okay, and these are the learning objectives for today's session. That at the end, you will be able to define sampling in the different key terms, and then classify sampling, give the different sampling methodology, and then understand the concepts of the different sampling methodology. Okay, so let's begin with a definition of what sampling is. Sampling is an act of studying or examining only a segment of the population to represent the whole. You see, in all research that we do not study the whole population because it is virtually impossible to study the whole population. So you study only a segment of that population, which we call the sample, and we want that segment of that population to represent the whole. So, what are the advantages of sampling? Why do we do sampling? Obviously, if we only study a sample, then if we study the whole population, expenses will be cheaper. You don't have to study the whole population, and then you don't spend much for the population for to study the sample, and results will come out to be faster because you study only a small segment than if you study the whole population. Now, it has better quality of information that you can obtain, and it can obtain more comprehensive data. You see, it doesn't seem logical. It seems logical that if you study only a small segment of the population, expenses will be much cheaper than if you study the whole population. And results will come out to be faster. That seems to be logical. But with better quality of information and more comprehensive data to be obtained, that does not seem to be logical. Why will we get better quality of information or obtain more comprehensive data when we study only a sample? Because you study only a few individual people, and then the kind of data that you get will be of better quality. You have more time to ask. You have more time to get more information, or better quality of information. I remember many years ago when I was connected with a NGO, non-government organization, where the community that we serve are the poorest among the poor in that community. And then one of the programs that we give to that community is PTB, control of primary pulmonary tuberculosis for children. Now, in that particular program, we enroll people who have primary pulmonary TB. And for an individual, for a patient to be enrolled in the program, we need to have some history taking to make the diagnosis of primary pulmonary TB. Now, one of the things that we ask during history taking is, ask of the mother is exposure of the child to an adult with TB. So I ask, for example, the mother of the child if there is in the family a person who has TB. And if the mother will say no, I will just go ahead, and then if there are many patients lining up, to be interviewed or to be examined, then I will just tick yes or no, no exposure to an adult with TB. But if I only have a few people lining up in the center, in the consultation, in the clinic, okay, then I ask the mother. I give more time to ask the mother. So I ask the mother if there are people in the family who have cough for a long period of time, or who have cough, who will always have cough every week or every other week, or time and again they will have cough. So I get more the information that I get will be of better quality. And then you can obtain also more comprehensive data. You can get more data from, because you only examine a few people rather than examine the whole, the many populations. So that's the reason why we can obtain more comprehensive data. A lot of information we can get from the respondents, precisely because we only have few people to examine. If you compare it, if you examine a big number of people. Now, and lastly, it is the only possible method for destructive procedure. Medtechs, for example, you know that you only examine a minuscule of blood. If you want, for example, to determine the CBC or of a patient, you don't get the whole of the blood of the patient, because that will be a destructive procedure. Medtechs will just get a sample, 5 ml, 3 ml of blood, to represent the whole. So it is the only possible procedure, it is the only possible method for destructive procedure. Okay? So what are the uses of sampling in public health? So we'll just zero in a lot of uses, as a matter of fact, of sampling in practically all aspects of our life. But in public health, these are the uses: to evaluate the health status of the population. You only get a sample, you don't need the whole population to examine. To investigate factors affecting health, we only examine a sample. To evaluate effectiveness of health measures, assess specific aspects in the administration of health services, and evaluate reliability and completeness of record system. You don't need to examine the whole population to be able to evaluate, to assess all of these things that we want to evaluate. Now, let's try to define terms before we proceed to actual discussion of the different sampling methodology. The population. Population refers to the entire group of individuals of items of interest in the study. So when we talk of the population, unless otherwise specified, we mean the entire group of individuals. When we say the target population, this is the group from which representative information is desired and to which inferences will be made. So we get a sample, and then later on we'll tell you what a sampling population is. We get a sample, and then we generalize results. As we said, we don't normally study the whole population. We study only a sample, and then from the results that we get in the sample, we generalize it to the target population. And then the sampling population is that population from which sample will actually be taken. I will give example in a little while so you will understand these different terms better. So where you get the sample, that is the sampling population. And then the elementary unit or the element is an object or a person on which a measurement is actually taken or an observation is made. So let's now give you an example of of these things, of this terminology, so you will understand better. Suppose I want to look into the proportion of medical students in Metro Manila who are smokers. Okay, my target population will be students in Metro Manila. That is my target population. Suppose I get samples from FEU, from UP, from UST, from UE, or from Fatima, or from MCU. So I get samples from these different medical universities. We call them the sampling population. So people, medical students in FEU, in UP, in UST, in UE, in Fatima, in MCU, is what we call the sampling population. So that's the sampling where the sample will actually be taken. Now, if an individual student A, for example, from FEU gets to be a sample, that student is an element or an elementary unit. And then again, the target population will be the medical students in Metro Manila. Okay? So this is how you distinguish the different terms, target population, where you want to generalize your results. These are the medical students in Metro Manila. And then the sampling population will be where you actually get the sample, that's your sampling population, in the person and object on which a measurement is actually taken is called the element or the elementary unit. Sometimes the sampling population and the target population can be one and the same. So if, for example, I want my target population, I want to look into the proportion of medical students in FEU who are smokers. So that means that my target population are medical students in FEU. And if I get samples from the medical students in FEU, that will also be my sampling population. In that particular instance, my sampling population and my target population are one and the same. So, and that is the medical students in FEU and RMF. Okay? So, sampling unit, that is the unit on which are chosen, the unit chosen in selecting the sample, and it may be made up of non-overlapping collection of elements or elementary units, meaning the sampling unit may be made up of non-overlapping collection of elements. That's the unit that is chosen in selecting the sample. Later on, we'll go back to this definition. And then the sampling frame is just a list from which one draws a sample. That's actually a collection of all, that can be a collection of all sampling units. So let's give again an example. Sometimes we don't have a sampling frame. Again, a sampling frame is a list from which one draws a sample. So if I want, for example, to get samples from a section in a class, I need to have a sampling frame or a list of all students in that section. So the list will be the sampling frame. Now, and each student is an element. But sometimes there can be no element, there can be no sampling frame where there are elements that can be used for sampling. So let's give an example. Suppose I want to look into the prevalence of malnutrition among preschool children in a particular barangay. So let me repeat that. I want to determine the prevalence of malnutrition in a particular barangay. So I need a sampling frame of preschool children in the barangay so I can get my samples. Except that there's no sampling frame for preschool children in a barangay. What do we have? What list do we have in a barangay? The list that we can have in a barangay will be a list of households. So if I want to get samples of preschool children I will get as my sample the household, and whoever is a preschool child in that particular household will be my sample, will be my element. In that particular case, household is a sampling unit. Household is a, as we said, the sampling unit. The sampling unit is the unit chosen, the household chosen in selecting the sample, and the sample are the preschool children. If that household has a preschool child, then that will become, that child in that particular household will be my sample, and it may be made up of non-overlapping collections of elements. So it may be made up of the different preschool children that do not overlap. That's why it's called non-overlapping collection of elements. Okay, so that basically is what is the meaning of the sampling unit. As a matter of fact, we'll be going back to this concept in a little while. Now, the next term that I would like us to understand is sampling error. That is the difference between the value of the parameter being estimated, and later on in the finals period, I think I will distinguish to you a parameter from a statistics, but the parameter is that which we want to estimate. So that's why the difference between the value of the parameter that you want to estimate and the estimate of this value based on the different samples. So as we said a while ago, we normally do not study the whole population. We study only a sample. We study only a sample. Now, if you want to estimate something in that from that parameter or from the population, we call that as the parameter. What you want to determine in the population is what we call the parameter. So for example, let me just go back to my example on the prevalence of smokers among medical students in FEU. If my population, my target population are medical students in FEU, which is a finite population. So suppose, for example, there are 3,000, just I don't know the exact value. Suppose there are 3,000 people, medical students in FEU. Okay, and then I want to estimate the proportion of medical students who are smokers. I get, for example, let's say I will just get about 100 after calculating for the sample size. Suppose I was able to get 100 as my samples. Okay, so if I will examine the whole population, let's say, for example, that out of the 3,000 population of medical students, suppose 300 of them are smokers. That's about 10% of 3,000. 10% are smokers. If I only get a sample of 100 medical students, the difference, so, and then I find out, for example, that the number of medical students who are smokers are 8 out of 100, so that's about 8%. The difference between the parameter, which is 10%, the actual value, the true value from the population, that's 10%, and then my estimate, the difference between the parameter and my estimate based on the sample, that's only 100. So the difference is what we call the sampling error. Because in statistics, you will always have a sampling error. The sampling error is something that is inherent in all samples. Because we don't study the whole population, there will always be a difference, and that difference is what we call the sampling error. But it is not an error in the sense that we made an error, we made a mistake. It's an error where the error can be actually specified. We can actually say that this much percent will be the margin of error. As a matter of fact, when SWS or Pulse Asia makes a survey and they talk of the margin of error, that is actually coming from the sampling error. Okay. So let's try now to discuss the criteria of a good sampling design. The sample that to be obtained should be representative of the population. A good sampling design will give a sample that will be representative of the target population, and the sample size should be adequate. So these are the criteria of a good sampling methodology or sampling design. It should be practical and feasible, and it should be economic and efficient. So these are the criteria for a good sampling design. Now, let's talk of the basic sampling designs. There are actually a number of basic sampling designs that a researcher can choose from. And the specific design that is best for a particular study depends upon the nature of the variables and the population being studied, the purpose for which the research is undertaken, as well as the availability of information relevant to the sampling procedure itself, like the sampling frame. So these are the things that we need for us to be able to use what sampling methodology that we need to use. Now, there are two types of basic sampling design, the probability and the non-probability sampling design. When we talk of probability, this is actually the scientific way of getting samples, and the non-probability is a non-scientific way of getting your samples. So let's talk first of the probability sampling design. In a non-probability sampling design, the probability that each member of the population to be selected in the sample is difficult to determine, or it cannot be specified. We cannot actually determine, we cannot actually calculate the probability that each member of the population can be selected as a sample. And in a non-probability sampling methodology, there can be a zero probability of a person being sampled, meaning a person may have a zero probability of being sampled. You see, a good sampling methodology should give all people the chances of being selected as a sample. In a non-probability sampling methodology, we can have a zero probability of being sampled. So these are the different types of non-probability sampling design: the judgment or the purposive sampling. In the judgment or a purposive sampling, we have a criterion or a set of criteria to get the sample. So that's judgment, we call it the judgment or the purposive sampling. So there is a set of criteria or a criterion that you use to get the sample. Suppose, for example, I want to look into the factors affecting control of DM. So my target population are people who have DM, diabetes mellitus. Now, if I get my sample in a clinic, in a diabetic clinic, that will constitute us. So my criterion for selecting the samples are people coming into that diabetic clinic. So that becomes a purposive or a judgment sampling methodology. There is a set of criteria for me to be able to select the sample. The next is accident or haphazard sampling. Accident or haphazard sampling is you meet people in the street, anyone that you meet, that's accident or haphazard sampling. Or for example, you go to the social media to get samples. That's accident or haphazard sampling. When people, for example, get responses, the TV stations, for example, get responses from people watching the televisions, that's an accident or haphazard sampling. Quota sampling, you're given a quota after you and you normally don't use a probability sampling methodology. You're given a quota, and then when you reach that quota, and then you're done. Snowball technique, this is normally used, the snowball technique is normally used for participants who are part of the hidden group of the society. So snowball technique, the technique in a snowball technique is you ask the person, you get a person, you get an individual to to be your sample, and then get a referral from that person where you where you interviewed. So for example, I want to look into the prevalence of drug drug use among prostitutes in Metro Manila. Okay, so I will use a snowball technique since drug addiction, drug use, and, and prostitution is part of the hidden group of the society. So if, for example, I am able to get one prostitute and then I interview her, and then after the interview I ask for a referral, so because they normally know each other, so a person that I interviewed last will give me another person who I can interview. So that's snowball technique. Okay, now in all this non-probability sampling methodology, we cannot generalize results from samples to population. Let me repeat that. When you do a non-probability sampling methodology, you cannot generalize results from samples to population. So if, for example, in the example that I gave you about number of prostitutes who are into drug use, if I am able to get to interview 50 prostitutes and then say 20 of them are into drug use, and then I can only say that 40% of the people that I interviewed are into drug use. I cannot say that 40% of prostitutes in Metro Manila are into drug use, because I cannot say that because I used a non-probability sampling methodology. Now, this brings us to the probability sampling methodology, where the rules and procedures for selecting the sample and estimating the parameters are explicitly and rigidly specified. This is actually the scientific way of getting your samples. The most basic type of this different probability sampling methodology is the simple random sampling, that's SRS. And its main characteristic is that every element in the population has an equal chance of being included in the study. I failed to say to you that in a probability sampling methodology, because this is the scientific way of getting the samples, you can actually infer results. You can generalize results from samples to population. So again, it is only in probability sampling designs where we can generalize results from samples to population. And as we said, the most basic of this is the simple random sampling. Okay. Many years ago, the simplest way of doing the simple random sampling is using the fishbowl technique, where you put, for example, get pieces of paper of equal sizes and then put numbers there that will correspond to the participants in a sampling frame. Put them in a box and then shake the box and then get one. That is a simple random sampling. If you do computer-generated random numbers, you are also doing a simple random sampling. During my time, we do the table of random numbers. We get samples from table of random numbers. That's also a simple random sampling. Okay. The next is systematic sampling. That's actually a variation of simple random sampling, except that now it's very much like a simple random sampling, but we normally calculate a sampling interval k, where where K is the ratio of the population size to the sample size. So this is the formula of the K, the ratio of the population size over the sample size. So if, for example, we have 3,000 medical students in FEU, and then I want to get a sample of 100 people, so I get first a K. I calculate for the K, so 3,000 divided by 100, and that is equal to 3,000 divided by 100, and that's equal to 3, to 30, to 30, that's equal to 30, and then K will be equal to 30. Tama ba? Yes, 30. Okay, K is equal to 30. Now, from 1 to K, from 1 to 30, I will select who will be the first participant using simple random sampling. So actually, the systematic sampling can be a combination of simple random sampling and then, of course, the systematic sampling. So I will first have to determine who will be the first participant from 1 to K or from 1 to 30. Okay, so suppose using simple random sampling, using a computer-generated random number, or even calculator, scientific calculator that will give a random number. Suppose I get 11. So number 11, we need a sampling frame. We need a sampling frame for both simple random sampling and a systematic sampling. We need a sampling frame. So number 11 in the sampling frame becomes my first participant. And then every kth thereafter, so 11, so and then I count 30, so that will be, just add 30, so 11 plus 30, so that will be 41. Number 41 will be my sample, my next sample, plus 30. Number 71 will be my next sample, and so on and so forth until I reach 3,000, and then I will get a total number of 100 people. That is a systematic sampling, very much like simple random sampling, except that it is systematic. Okay, I failed to mention to you that we use simple random sampling and systematic sampling when the population is homogeneous. There is no heterogeneity in the population. So we can use simple random sampling and systematic sampling. And I normally use a systematic sampling if I'm doing I'm collecting data from a medical record. So a systematic sampling will be a lot better than a simple random sampling if you are getting population from the medical records. Okay, the next is a stratified random sampling. We use the stratified random sampling when the population is heterogeneous. I told you a while ago that we use simple random sampling and systematic sampling if the population is homogeneous. If there is heterogeneity in the population, meaning differences in the characteristics of people, then I need to stratify. I need to do a stratified random sampling where I stratify the population into homogeneous groups. So the population is first divided into non-overlapping groups called strata, and each stratum becomes homogeneous, and then a simple random sampling is then selected from each stratum. A simple random sampling or even a systematic sampling will then be used from each stratum. Let me give you an example of a stratified random sampling. Suppose I want to determine the prevalence of ascariasis among the school children in Quezon City. Prevalence of ascariasis. Now, with prevalence of ascariasis, there could be a heterogeneity in the prevalence of ascariasis among school children depending on the type of school that the child is enrolled in. So children enrolled in public schools may have higher prevalence of ascariasis than children in the private school. So I need to stratify. I need to do a stratified random sampling. I need to group my population into two groups, into the private schools and the public schools, and doing so I make the group homogeneous. So all children in the public schools will have homogeneity in the prevalence of ascariasis. In much the same way, children in the private school will be homogeneous. So I need to divide the population into homogeneous group. We call it actually the stratified random sampling. And from each sampling, from its group, from its stratum, we select the population using simple random sampling. There is what we call a proportionate stratified random sampling. Proportionate means the sampling, the number of people sampled from each stratum will be proportionate to the total population. So just give you an example. If all, just for easy calculation, if all children, school children in Quezon City, for example, is 10,000, okay, and then 6,000 of them come from public schools, and 4,000 of them come from private schools. Okay, so 60% are from public, and 40% are from private. And if I want, for example, to get 1,000, suppose I am able to get a sample size of 1,000, I calculate, for example, the number of people to be sampled is 1,000, for example, just for easy calculation. And then because 60% of the population come from public schools, I will get 600 children from the 6,000 public school children, and I will get 400 from the 4,000 private school children. That's a proportionate. So the number of people that I get in the public and in the private are proportionate. Okay. So cluster sampling, when the sampling frame is for elementary units is not readily available, or when cost considerations are important, cluster sampling is often resorted to. So just to review, give you a little review, as we said, in simple random sampling, in systematic sampling, and in a stratified random sampling, we need a sampling frame. Again, the sampling frame is just a list of participants, of people that you want to get as samples. Now, in a cluster sampling, we normally use cluster sampling if sampling frame is not readily available, meaning we don't have a sampling frame for elements, so we resort to cluster sampling. In cluster sampling, okay, these are the steps that we use in cluster sampling. The population is first divided into clusters, and each cluster serves as sampling units, and a sample of units is selected. Okay, so again, we go back to this concept of sampling unit because we don't have a sampling frame. That's not the sampling frame for elements is not readily available. So we divide the population into clusters, and each cluster represents a sampling unit. Okay, now this clustering is different from the stratum or strata in the sense that clustering is already there is an inherent division in the population when we say cluster. And we use cluster sampling if the population is homogeneous. if the population is homogeneous. Let's give an example. Going back to the example of proportion of medical students who are smokers. Okay, so in FEU, for example, if I do, if I, of course, there is a sampling frame of medical students in FEU. We can have a sampling frame because we can easily get a list. But suppose there is no list, just for the sake of discussion. Suppose there is no list of sampling of elements or sampling frame for elements. So I divide the population into clusters. Normally, medical students are divided by year level. So first year, second year, third year, and fourth year. So that will be my first cluster. So as I said, we divide the population into cluster. So each cluster, the first year, second year, third year, and fourth year, serves us. Each of these serves as the sampling unit. So first year is a sampling unit, second year is a sampling unit, third year and fourth year are sampling units. Okay, every element found in each sampling unit drawn as a sample, every element, meaning all medical students in the first year, all medical students in the second year, third year, and fourth year, every element found in each sampling unit drawn as a sample may or may not be included in the study because just going back, so we select a sampling unit. So there are 4 sampling units: first year, second year, third year, and fourth year. I select only 2 sampling units. Okay, I select 2 sampling units. So suppose I am able to select the first year and the third year. So every element found in each sampling unit drawn, so all first year medical students drawn in the sampling unit in the first year, and all medical, every element, just say muna, every element may or may not be included in the study. So all first year students, all third year students may or may not be included in the sample. If only a subset of the sampling unit in the cluster is selected, meaning not all first year is included in the sample, not all third year is included, only a subset of the first year, that sampling unit in the first year is selected, we have a multi-stage sampling design. Then we'll go back to this multi-stage. We'll first talk of the single stage because this is easy to understand. Now, listen, if all the sampling units in that cluster is selected, all students are selected, first year, all third year are selected, then we have a single stage cluster sampling, meaning you're done. That's one stage. So all first year medical students become my samples, all third year medical students become my samples. And then, as we said a while ago, if not everyone, not all first year are included, then we have a multi-stage. We have many stages. Multi-stage means many stages. Okay, so and this brings us to the multi-stage sampling design. When the sample survey to be conducted has a wide coverage, as a nationwide survey, many times a multi-stage sampling design is used. So we use a multi-stage sampling methodology when we are doing a nationwide survey. So these are the steps. The population is first divided into a set of primary or first stage sampling unit, and a sample of each unit is selected. So let's give a nationwide survey. Suppose I want to look into the number of high school students who are into drug use nationwide in the Philippines. So a nationwide survey, I want to determine the proportion of high school students who are into drug use. I first divide the population into regions. into regions. So there are, how many regions do we have? 14 regions we have here in the Philippines. Okay, so I divide them into 14 regions and then get a sample. So we first divide in a set, so that's the first stage by region, and a sample of each unit is selected. So I get, for example, region 1, region 7, using simple random sampling. Using simple random sampling, I select, say, for example, 8 regions in the Philippines. So I don't know. So one of them, for example, is NCR. So region 1, region 3, whatever, using simple random sampling. Now, the next step is each primary sampling unit included is further subdivided into secondary or second stage sampling unit, from which a sample will again be taken. So from each region selected, we again subdivide each region by province. Subdivide the region by province, and the province will be the secondary stage. The primary stage is by region. The province will be by the second stage will be by province, and then the procedure continues until the desired stage is reached. So until you reach, for example, after the province, you go to the municipality for each province selected in each region. So for example, in NCR is selected. We subdivide the population into cities, and then we just get, say, for example, 5 cities, and then for each city, we again, city will now be the secondary stage. The third stage will be by school, the schools in those cities, high schools in those cities, until the final stage is reached. So so you only need a sampling frame for the final stage. So if the final stage, for example, is the actual high school in that particular city or municipality, then that will be the final stage, and then we just get elements. So that's the reason why in a nationwide survey, we just need a sampling frame for the last stage. There are multi stages. So I think that will be all for the sampling methodology. Thank you for listening.